Our next demonstrator is Kobus Van der Merwe. Kobus Van der Merwe is a professor at the University of Utah, the School of Computer Science. He previously spent 14 years at the AT&T Research Labs. In fact, in 2010, he won the Science and Technology Medal from AT&T for his work on intelligent route control. I will say that the demo that you're about to see, I think, is very important in terms of future directions. You may remember yesterday from my talk that I believe that virtualized networks, networks that allow you to have different properties than the physical network, maybe more reliable, maybe more constrained. Maybe you'd like to take this physical therapy information and keep it more private. All of those things require putting this into a separate virtual network. And there's some very pioneering work that's been done by Professor Van der Merwe he's going to tell us about. Kobus?
I can get my slides on. There you go. Thanks, Glenn, for the introduction. This is joint work with my students Junguk Cho and Makito Kano, and they are manning our demo, and we still have our demo up. So if you haven't seen it yesterday, please come by. We're right behind us. It's also joint work with my colleagues at the University of Utah, David Johnson and Brent Eliason. So the motivation, I don't need to tell you this, everything is networked. All applications, business applications, pretty much assume that there is a network. And this is, of course, true in healthcare as well, from things that are pretty mundane, maybe like accessing patient records, to things that are more sophisticated, like the demo we just saw, remote diagnosis, consultation, in-home monitoring, et cetera, et cetera. And then there's also the more pedestrian vocational users of the network. And the key thing here is that the individual that use these applications typically want to do that at the same time using the same device. And these devices are often mobile. And the problem here is that these applications have very different security needs in terms of what is allowed, the data that they can access, and how you should manage that. And the fact that these devices are mobile also means that they're typically not the part of your managed network, right? You have your physician coming in with their tablet, and this is the device that they love and want to use, and they want to use that for all these different functions. The problem is, maybe last night the physician's children played video games on it and downloaded some malware on this same tablet, and now they're accessing your medical records, and there you go. You have data exfiltration, and your medical records are being leaked, right? So this is essentially the problem we're addressing. So current approaches to address this problem, well, you can scan the device when it shows up on the network, make sure its patch levels are up to date. But the problem is, even a device with patch levels up to date might still have malware running on it, right? Another approach is making use of thin clients, and this is a really good approach. So you have your actual application running in a server farm somewhere, and you have a very thin client on your device to access it. However, this constrains the type of applications that you might be able to run, especially if there's latency or resource requirements that would make the application work better locally. And finally, we all have these very sophisticated network and server access policies, and this is the way we try to protect against data leakage. The problem is access control policies opens the gate once you authenticate, and then once the gate is open, all bets are off. There's no protection of that data, right? It just allows you in or out, but once you're there, there's no protection. And of course, we're talking about this problem in the context of healthcare, but this generalized to a lot of applications that want to access sensitive data. And I got this list from our chief security officer at the University of Utah. And this is the list of things that keep him awake at night, right? So this is the requirements that are associated with different data sources on the network, and they all have different requirements in terms of how they should be accessed and who might access them and how they should be protected and managed. So it's actually a fairly broad and general problem. Right, so what is our approach? Basically, what we want to do is we want to take the application and the data that it accesses, and we want to contain that in an end-to-end context, right? And so this is what we do. We, on the endpoint, so think of the endpoint is your laptop or tablet or smartphone. We want to take all the existing non-critical applications, we want to put them in their own little containment so that they're out of the way and they can't interfere with our sensitive applications. And then when you run your sensitive application or your application that accesses sensitive data, we want to put that in its own little containment, its own little container. And then we want to extend a context from these containers into the network and make sure that the sensitive data that you access stays within that containment in an end-to-end way, right? So basically, from a technology perspective, on the device, we're making use of lightweight containment mechanisms. And within the network, we make use of SDN. And because we have these mobile devices coming into the network that are not really trusted, but at the same time, you have to trust them because you want to make them part of your network, right? And so the way we do that is by essentially doing a fairly simple inter-SDN domain interaction. So we have our managed trusted enterprise network, and then we bring in this mobile device, and really we treat both of them as two SDN networks, and there's inter-domain communication going on to tie the two together, but it's in a little bit of a handoff approach, so we don't have to trust the device completely. So a little bit more formally, our threat model, well, we're concerned about the security and the performance of healthcare applications. And we assume that the healthcare application itself can be trusted, which is a little bit different from your normal threat model when you deal with end devices, where typically you want to protect the device against applications that you don't trust. So in our case, that's a little bit the other way around. So some specific concerns then, unauthorized access, that's a critical one. Data exfiltration, we want to make sure that this sensitive data don't leave the environment. Resource guarantees and denial of service, which are sort of flip sides of the same coin, especially for applications that has real-time guarantees or robustness guarantees or requirements from the network. All right. So the components of our architecture on the endpoint, so again, endpoint here, think tablet, laptop, something that you carry around. The first thing we do is we take your set of default applications and we put them in a container. Again, we make use of containment technology. In our case, we run on Linux, so we make use of lightweight Linux containers. And by moving all of these applications into their own little container, we essentially reduce the trusted computing base, right? So almost the only thing left in the default namespace is this SeaCat trusted daemon. And the purpose of the SeaCat trusted daemon is twofold. First, it creates these containers for us on demand for the sensitive or the applications accessing sensitive data. And then the second thing is it also deals with the little SDN network in the device, right? So it's a very small network. It's a single switch network, in fact. But we have on the device, we run a little open vSwitch. And it's the purpose of the function of this SeaCat trusted daemon is to configure that network to create our end-to-end context, as we'll see momentarily. Right. So in the enterprise network, we similarly assume that this is an SDN network. We have a SeaCat server that manages that network. Again, two functions. The first is to create these secure contexts on demand within the enterprise network. And then the second one is, and this is where we have the inter-domain SDN interaction, it communicates with the SeaCat trusted daemon on the tablet, on the endpoint, to do our end-to-end interaction. All right, how do we put it all together? The key thing that we use here is we use a single sign-on, right? So except the single sign-on is a little bit more involved than your normal single sign-on, at least behind the scenes. But from a user perspective, if you want to access your protected data, you do single sign-on, like what you do today. Except, once you're authenticated, instead of just doing some manipulation of cookies and allowing you access to a server, all of this signaling and mechanisms are triggered behind the scenes, and we create the end-to-end context. Right? So a few number of slides just to show this pictorially. So let's say this is our starting position. We have our enterprise network, default context. You can access the internet and non-sensitive applications. This is your network as you have it today. Right, so now we have our mobile device coming into this environment. It associates with this network. Again, business as usual. With the exception that at this point already, all of our non-sensitive applications have been contained in their own little container. So we can access this single sign-on and the SeaCat server behind that, again, from the default context. So now, when a user wants to access sensitive data, medical records, for example, they would start a browser, point it to this resource, and do single sign-on authentication. If that succeeds, at number 2 here, the context gets created in the enterprise network. The next thing is that SeaCat communicates with the trusted daemon on the tablet. The trusted daemon in turn creates a new container for us. It also plumbs through the network connectivity through that single switch on the tablet, on the endpoint device, and we end up with an end-to-end connection. Our application starts up, and it's contained within that container through the network context, accesses the secure data, right? And it's like a completely separate virtual network. You can't access it from the outside. That application can't go outside of its container. It's completely isolated. And when the user terminates the application, everything gets cleaned up, and you end up with the initial state again. It's as if nothing has happened. All right. Our demo, we have a demo set up, like I said before. For our endpoint, we make use of a Linux tablet with Wi-Fi interface. For our enterprise network, we have an SDN-enabled Wi-Fi access point. We also emulate a more comprehensive enterprise network in a mininet instance, just to make it simple to do a portable demonstration. We have a single sign-on. We use Shibboleth. You can use anything else, but that's a commonly used single sign-on mechanism. And then we run this OpenMRS medical record system within our container to demonstrate our framework. Right? And pictorially, this is what our demo looks like. Finally, what's our status and plans? Well, we have this working prototype. We are currently focused on the specific application of access to electronic health records. But SeaCat really is a general application framework. And so we want to explore other applications, both in healthcare and other applications that accesses sensitive data. And we are definitely interested to explore taking this beyond a prototype, especially if there are interested use cases within the US Ignite community. Thank you.
And you're going to tell people to come back with their lunch and sit down here, right?